Hello everyone, welcome back to my YouTube channel. Welcome to those of you who are new here. My name is Fatima and this is my YouTube channel where I talk about ways in which you can do better in your final exams, especially matriculants. So today I am going to focus on scientific skills in life sciences. So another easy way to pass life science, to do well in life science, is to know your scientific skills. So knowing your scientific skills is like knowing 25% of your paper. So scientific skills count 25% for paper 1 and 25% for paper 2. So it's 25% of your final mark-ish, I think. Yeah, so it's 25% of your final paper combined. So I have this document with me which was given to me by my teacher from last year. It's very handy. So I will be going through this document with you, skimming right through it and looking at the important things like your dependent variable, independent variable. So please do stick with me, don't go anywhere. And for those of you who want to have the whole thing, you can email me. I will attach my link in the description box below. You can send me the email or iMessage. It works for iMessage as well. You can send me an email or iMessage and I'll send it to you. Okay, so let me go into this document with you. So the first page is mainly the introduction, so I'm not going to go much into that. So you can read through that for yourself. And let me move on to the important stuff, more important stuff. Everything in here is important. Let me move on to the more important stuff. So you need to know what a variable is. So a variable is any item, factor or condition that can be controlled or changed in an experiment. So we have two of these. We have the independent variable and we have the dependent variable. So the independent variable is basically in the name. So you are in control of the independent variable. The independent variable is the one thing you may vary and see how it affects the other dependent variable. For example, so this is the variable that we control. So in my graph, for example, I want to test the growth. This is the x-axis. So the independent variable is always on the x-axis, right? So hypothetically speaking, we want to test the effect of water on the growth of a plant. So here we determine, okay, now we're going to give this plant 1 liter of water. Here we're going to give this plant 2 liters of water. Here we're going to give this plant 3 liters of water. So we choose the independent variable ourselves. So the dependent variable, that's one thing, that's the outcome we do not control. For example, now I gave this 1 liter, right? And maybe the plant grows 3 centimeters, right? And here it grows 10 centimeters and so on and so on. So this is the one thing that we do not control. It is the outcome. So that is the dependent variable. So the dependent variable, it's in the name. It's dependent on the independent variable. So this outcome depends on this, what we control over here. So the dependent variable is always on the y-axis in our graphs. And then the control variable, the fixed variable, is the one thing that we keep constant throughout the experiment because we can only change one factor at a time. For example, isn't it we're measuring the impact of water on the growth of a plant, right? So we have to keep things like temperature constant, right? The same plant, we have to use the same plant because different plants grow differently. So if we use different plants and for this experiment, the experiment is not going to be valid because we have to see this specific plant because they just grow differently. The temperature kept constant because that also plays a role. The sunlight, we give it the same amount of sunlight and stuff like that. It's kept in the same area, the type of soil that we are using because soil, it plays a significant role towards the growth of a plant. So remember, this is just an example. So moving on, I am moving on to the hypothesis. So what is a hypothesis? A hypothesis is basically an educated statement. So it's a statement, not a question. So for example, right, in my experiment that I made up, a hypothesis, maybe I can say, a hypothesis cannot be wrong or correct. Even if you just say, as the more water I give the plant, the less it grows, right? So that's a hypothesis, even though that's not correct, like that's not what the outcome will be. I can make a hypothesis like that, or I can say the more water I give my plant, the more it will grow. So that's a hypothesis. It's a statement you make before you do your experiment. So you just guess. It's an educated guess basically. So you just say, okay, this will it grow faster, no, it will grow slower or something like that. So it's a prediction. And so you can read all of that. I'm not going to go into it. And then, okay, a hypothesis. This is okay. Another thing, your hypothesis needs to contain your independent variable and dependent variable. Otherwise, it is incorrect. And here are the guidelines. You're going to read through that. And the aim. So the aim is basically you state what you want to do. So state what you are going to be investigating. So for example, in my experiment here, I'm going to say my aim is to test. Let me just write it. My aim, I don't know if this pencil is visible. My aim is to find out, or maybe test whether my plant will grow faster as I increase my water content, right? So that's an aim. So you can say to determine, to show that, to investigate, to find out, to observe, to measure, to CF. So relate directly to the question you are asking. So here are the examples as shown below. You can read through that. And then validity. So I've expressed this before. What is validity? So validity is what makes your experiment valid. So such things as control, fixed variables, and stuff like that. So you can only change one factor at a time. The samples must be chosen randomly. You have to use appropriate apparatus because your tools are important in the outcome of your results. You have to use a reliable, maybe for example, I'm using a ruler to measure the growth of my plant. I have to use a reliable source and things like that. So that is what validity is. So you can think anything that makes sure that your experiment is valid here. So that is what is being asked as validity. So you need to know the difference between validity and reliability in order to answer a question like this. Now I'm going to look at reliability. What makes your experiment reliable? Can we rely on the results that you gave us? Like for example, can you guys rely on the fact that I said as I increase the water content of the plant will grow faster. So the reliability is that if you go and test this out yourself and use this, you must be able to get the same results. So that's what makes it reliable. I can do this by increasing my sample size and seeing, do I still get the same results? I have to do this over and over again. I have to repeat this experiment to determine whether this is going to be reliable. Someone will do this and they will get the same results. So you can find out here how to write your results and everything on reliability. So I am going to move on. And here it shows you how to draw a table. I'm not going to go through that. So it's a way of summarizing your data, right? And analysis of a data. So to make your data meaningful for you, we do this in doing graphs. So how to draw graphs in science, you need an origin, so where your x-axis and y-axis meet, your y-axis and your x-axis, and you need to have the dependent variable on your y-axis and your independent variable on your x-axis. That's just the way it is. So your independent variable always represented by the x-axis and stuff like that. You can read through this and then determine the scale of your graph. This one is just important because it really affects how your graph looks. So determine the scale of your graph. Okay, maybe here they say they're moving in 0, 1, 2, 3. You cannot just come here now, okay, you're tired of going 0, 1, 2, 3, then you're just gonna say 10, 20, 35. You can't do that. It really affects your graph. And here it always must be a consistent scale, your consistent increments, and always label. Like labels are important. You don't label, you're losing marks. So you need to have a title here. You need to label your independent variable. You need to label your dependent variable. So that's just the way it is. because how will the marker know what you put here and what you put there? You have to label, you have to show them that you know what you are doing and you're not just guessing through this whole thing. Okay, I am moving on. Plot the data points. Okay, you plot, draw the graph, draw a curve or line that best fits the data points, title the graph. See, title the graph. And here, bar graphs. So I'm not going to go into detail because I made separate video for these graphs. So a bar graph is the independent variable is discontinuous, so it's discrete data, right? Hence the bars are far away from each other, different things, right? So remember, number of learners is your dependent variable on the y-axis, and the x-axis. Always remember that. And then the following features, the bars don't touch each other, they are the same width. You can tell the distance between the bars are equal, so that's just one of the things you have to look out for when drawing your bar graph. And your line graph, okay, titles, you see there's always a title, your y variable, your x variable, so you can see these features. And you always need to determine a scale, and both dependent in a line graph, both dependent and independent variables are measured in numbers. So that's one thing you should know. The relationship, and yeah, the relationship is continuous like this. And always make sure you don't just leave your graph like this, like you leave this one out. Don't just let it hang in the air. Always ground it back to where x is equals to 0. So sometimes it may be here at the origin, but always ground it back to where x is equals to 0. And then a histogram. So a histogram is similar to a bar graph. Only difference is that the bars touch each other, and this is used for continuous data. So here the features always have, you see, they always label the stuff. You also need a heading here. They did not include that, but always label your stuff. Here are the steps, but I made a separate video on this, so worry not, I will be dropping it. And here's an example on how to draw your bar graph. And here I am moving on to pie chart. So it's a visual representation of percentages as a relative proportion to the total of the circle, which is 360 degrees. So the percentages in terms of 360 degrees of the circle, and this is how you draw it. So you find your total and then you find your percentage. So for example, favorite types of movie: 4 people love comedy, 5 people love action, 6 people love romance, 1 person likes drama, 4 people like sci-fi. The total is 20. So I need to find out the percentage of people who like comedy, action, romance, drama, sci-fi, and then from there I convert these percentages into degrees, because we are working with degrees here, not percentages, because a circle is 360 degrees. So I can do that by saying times my percentage times 3,6, or times 360 over 100. That's how it is. And moving on, I hope I'm not moving too fast. Okay, validity and reliability again, and you always need to know how to conclude your data, right? Sorry. Okay, here, this one is important. I'm going to work it out with you, for you. Okay, so now moving on, percentage increase and percentage decrease. So I'm going to start with percentage increase. Let me just do this and cover this like that. Okay, so Pretoria High School for Girls had 200 girls in 2004. The numbers have increased to 350. So calculate the percentage increase for girls in the school. So how do I find my percentage increase? So initially, I'm going to, first you need to find the difference, because you need to know what changed, right? So I'm going to find the difference. It's always take the big number 350 minus 200, which gives me 150, right? So now I go back, I take this number and then I divide it using the initial number. Always use the initial number, right? So I take the difference over the initial number times 100 to find my percentage increase. So I can just cancel like this. 150 divided by 2 is 75%. So it increased. You can't just leave it like this. You always say it increased by because you did not answer the question, you just did a calculation. So it increased by 75%, right? And now percentage decrease. So percentage decrease. Let's read the case study. Nadine weighed 55 kg when she was 16 years old. At 21, she weighs 49 kg. So find the difference first. So it's 55. Always take the big number. So it's equals to 55 minus 49, which gives us 6. Okay, so now we take the difference minus the initial number. So initially she weighed 55. 55 times 100 equals, take my calculator, I say 6 divided by 55 times 100. I always round off my answers to 2 decimal places unless stated otherwise. So it's 10.91%. So her weight, I was not specific here, her weight decreased by 10.91%. Okay, let's check. Here they rounded it off to the nearest whole. So I don't know, you can, but I always make sure I round it off to 2 decimal places because that's what the instruction says on the question paper. And okay, now moving on. Here are examples. You can do that in your spare time. And ratios. So a ratio, okay, so it simplifies the numbers in the simplest form. So always remember the order of the ratio is given in the question. Okay, so you use the order that they give you. So what I'm going to say here is Morgan has 9 cows, 3 dogs, and 27 cats on her farm. What is the ratio of her animals in her farm? So it's 9. So they say she has. So for ratios, remember we always use colons, right? So 9 to 3 to 27. But with ratios, the thing with ratios is you need to leave it in its simplest form. Like you can't leave it like this. It's like just writing the question over again. So you need to leave it in the simplest form. By doing that, we find the highest common factor. So the highest common factor here is 3 because I can see there are multiples of 3. So this I divided by 3. It will be, or I can just do this. It will be, 9 divided by 3 gives me 3. 3 divided by 3 gives me 1. 27 divided by 3 is supposed to give me 9. And like that, we have the ratio. Simple. And then the trend is determine the trend. So the trend is basically the outcome of, like, what you can observe is going on in this graph. So for example, this, if you do physics, you should deal with this a lot, like this, right? So we can see, so remember this x-axis and y-axis. The trend here, we can see that as the independent variable increases, the y variable increases as well. So yeah, until a certain point and stuff. So we can tell. But okay, when you write down the trend, right, you can't say as the independent variable increases, the dependent variable increases. You have to, for example, isn't it we're talking about water content? Okay, let me just make an example. And growth of a plant. Right? So as we increase, so my trend will be as we increase the water content of the plant, given to plant, the growth of plant increases. Or maybe the rate of the growth of a plant increases. So that's what a trend is. Or you can use things like inversely proportional, directly proportional. And here is another. So a trend is the same relationship. Sometimes they ask you, what is the relationship between, for example, amount of nitrate to the yield of grass. So as, let me observe this here. So 0, 225, 425, 650, 700, 750, right? Here, 8, 14, 18, 20, 20, 19. So this side we can see it's increasing and this side we can see it increases, but here it drops again. Okay, so what is the relationship between these two? I can say that this is our x variable, right? So it's our independent and this is our y variable. So I can say that as we increase the amount of nitrate fertilizer added to crop per hectare, the yield of grass increases until a certain point. So because here it decreases, so that means this is the maximum we can put for the yield of grass to increases, because too much fertilizers actually isn't good. So this is the maximum, right? It's until to a certain point. So as the amount of nitrate, see the answer, it's being specific. We can't say as this increase, as the independent variable increases, the dependent variable increases. That's not what they're saying here. As the amount of nitrate fertilizer increases, so too does the yield of grass increase up to a certain point. So that's it from me with this document. Remember, I can send it to you, so I will be going through the other videos with you, and the other graphs with you. And don't forget to like, comment, share and subscribe. So I'll see you in my other videos. Okay, and that is it for this video. Don't forget to email me or iMessage me for the full document. I'm willing to send, and good luck. And don't forget to do as many questions, including scientific skills, and go back to the memo and check where did you go wrong. Remember, it's all about practice. You have to learn effectively. So if you don't practice, you won't know how to do it in different situations. So yeah.